determine whether the series is convergent or divergent. We got a series n from 1 through infinity of negative 2 to the n over n. Negative 2 to the n is same as negative 1 times 2 to the n. So negative 1 to the n times 2 to the n. So negative 1 raised to n, when we run from 1 through infinity, it gives us negative 1, positive 1, negative 1, positive 1. So this is an alternating series. And we know that using the alternating series test, we can confirm only the convergence. But the question here asks whether the series is convergent or divergent. So we are not going to use the alternating series test. So we want to use something with absolute value so that this negative sign will be gone. This is positive 1, negative 1, etc. So let's use limit of, ratio test, an plus 1 over an when n goes to infinity. An means the given term, whatever we have, negative 2 to the n over n as an. Then an plus 1, we just replace n by n plus 1. Negative 2 raised to n plus 1 over n plus 1. Now we divide an plus 1 by an and take the limit. Take the absolute value and limit. Let's do that. Using the ratio test. So limit n going to infinity of an plus 1 is this. So negative 2 raised to n plus 1 over n plus 1 divided by, so I'm using this, an, which is this, negative 2 to the n over n. Okay. Now let's evaluate this limit. So as I showed on the top, so let's change this division into multiplication. So this fraction flips, and this can be separated factor in this way. So this is pretty much negative 1 raised to n plus 1 times 2 raised to n plus 1 over n plus 1. This division into multiplication, so this fraction flips, n over negative 1 to the n, so negative 1 times 2, so 2 to the n. So this limit is in fact, so when we take absolute value of this, which is n plus 1, this is positive 1, negative 1, etc. This is gonna go to 1, just positive 1 all the time when we take absolute value. And same thing here, this is gonna go to 1, positive 1 all the time when we take absolute value. Okay, so that leaves, so we can take the absolute value now, or everything else is positive, so we don't need absolute value anymore. Now 2 raised to n plus 1 and 2n. We know that 2 raised to n plus 1 is same as 2 raised to n times 2 raised to 1, which is 2. So this can be factored as 2 raised to n times 2, so that we can cancel. Okay, all over n plus 1, that's plus, so we cannot cancel anything, that's is a block, times n over 2 raised to n. Now as you can see, 2 raised to n from top and bottom cancel. Now we can take the limit n going to infinity of 2n over n plus 1. This number 2 times n we can pull all the way outside if we like. That leaves n over n plus 1, which is 2 times Now we want to find this limit. We can think like x on the top and bottom when x going to infinity. So pretty much we are finding the horizontal asymptote if we think about x, and when they are 1x, they have the same exponent, so this will be just 1 over 1. So this limit will be 1. So eventually when n goes to infinity, n and n plus 1 both go to the same place, which is, that's why the ratio is 1. So this is 2. So we use the ratio test and found that the limit is 2, which is in fact bigger than 1. That means the series diverges because the limit is bigger than 1. If the limit is less than 1, the series converges. If this is 1, then the test fails. Okay, the series diverges in this case.